animation to animation. And it'll replace this controller with a Bezier controller, XYZ controller, basically a wire parameter that'll handle all X, Y, and Z. So now that I've connected it up, you can see that I'm getting a one-to-one relationship on the control. But again, like I said, without the parent node underneath here, you can see now when I push it sideways, it's not going in the direction of the X that we'd expect. It's because it isn't a true zeroed out value. It's not truly zeroed out in rotation. It is currently taking on its parent's axis orientation. So you can see that that's the direction that X is being pushed. So we have to actually make sure that we always parent this up to a node that is aligned to it, orientationally aligned to it. Now what we're going to do is we'll go back here, say group each object, and we'll drop that in there. And now you can see if I go back down, this is the actual one that is, its parent now is aligned to it. So now when I move this control, it's moving in the direction that we expect. It's because it's moving around that parent's axis. So if we have to adjust the actual orientation of this, the way that it's going to push this joint, we have to change this root one, this parent one here, the one that's at the top of the hierarchy of these point helpers. And that will affect the direction that this one moves. You can see that this object's parent is the actual jawbone again. It doesn't matter though, it's this one that's having been wired, and it's this one that's going to be affected by how that orientation is being affected. So you can see there's, if you get that error happening, that's where it's coming from. So now you can see that I can push this, and it's pushing that joint in the direction we expect it to. However, it is going one-to-one. What we might want to do is we might want to multiply it by something. So times 0.7 or something. Try that. So it doesn't move quite as much, or we could say 0.6, and now we can play with the amount that's actually going to be moving with it. And so we're getting a little bit of a compression on the corner of the mouth here, which is what we're looking for. So we can find that right value. Now the rotations, while we're here, we can do those as well. We're going to connect up the rotation, the animation, to this one. This is going to become a quaternion again. And unfortunately, you can't just multiply a quaternion by 0.5 and get the half of the rotation. You actually have to use a slurp algorithm to do it. That can be looked up in the help, but it's easy. It's slurp. And then what you want to give it is you need to give it actually two quaternion values. In this case, it's starting value and its end value. And then you need to give it a third value, which is a float value from 0 to 1, which is the interpolation value. 0 would give you all of 1. 1 would give you all of the other quaternion that you're passing it. So the first quaternion is going to be essentially the identity quaternion. So an unrotated quaternion, which is the initial starting point of this object, because it's parented up to something that's aligned to it. Its initial quaternion value would be a standard identity quaternion. So you write a quaternion by quat 0 space 0 space 0 space 1 and bracket. And that is a quaternion value that has not been rotated at all. Then you pass it the quaternion value that we're passing into the expression, and that's the one that's coming from our control object. And then you pass it the amount of interpolation between the two quaternions value from 0 to 1. So 0.5 would be somewhere in between. So now when we rotate this, we're actually getting half of the rotation here at this end. If we say 0.1, we'll get very little rotation at this new point helper. And of course, if we set all the way to 1, we'll get 100% of the rotation. So a 1 represents all of the track that we're inputting from the control. A 0 would return all of the identity quaternion and get us nothing at all. And then somewhere in between. So let's do 0.5 right now and try that and see if it's the kind of rotation that we want out of it. Maybe we want a little bit less of the rotation on it,